Trains on platform. The trains on platform are one of the most common example of relative motion that we are able to view on daily basis. Let's say there are two trains stationary on a platform for quite some time. Now train 1 slowly is moving, which is relative to the train 2. The two motion of both the trains are said to be in relative to each other. The passengers on the stationary train 2 will seem to be in motion relative to the passengers on the train 1 which in motion. By this way we are able to understand what relative motion actually means. When we consider the term motion, there are 4 directions in which any object is said to move. The 4 directions are very much familiar to us. They are north, south, east and west. So when the train 1 moves in the north direction, the train 2 moves in the south direction, the motion of both the trains are said to be relative to each other. Train passenger and observer. Now let us consider the train to be stationary in the platform and an observer to be on the platform, sitting on the bench. When the train slowly starts to move, the observer appears to be in motion to the passenger on the train. Basically here the frame of reference concepts dives in, that is, the frame of reference of the passenger on the train is said to be stationary relative to the frame of reference of the observer on the platform. The passenger on the train in motion observes the observer on the platform to be in motion because the motion of the train is in the direction opposite to that of the observer on the platform. In such cases, both the observer and the passenger appears to be in relative to each other. Two cars in motion. Consider two cars to be in motion and on the same road. The passengers of the cars assume that the other car is in motion, but their own car is stationary compared to that of other car. Now for example, let us consider both the cars to be in motion in the same direction. The relative's motion is said to add up. Consider the first car moves with 60 km/h in the north direction and the second car moves in the same direction with 40 km/h. The relative speed between the two cars will be the sum of the speed of both the cars. When the cars are said to move with same speed but in different directions, then the relative speed will be a subtraction of the two cars. So when we consider the motion of the cars to be relative to each, car 1 seems to be stationary to car 2 and vice versa. Park location to an observer. Let us a simple play to explain this better. The children were allowed to play in the evening in the park, but the location of the park was unknown, so the caretaker inquires the park location to the local person. The local person knows the direction and says that the park is located to their north, but before that they will have to cross the signal. So now let us go detailed about this. The entire group moves north direction and after crossing the signal they end up at the park. But also there are other group of children coming to the park from the south direction where they will reach the park without having to cross the signal. There will be a motion which is relative to both the group of children coming to the park. For the group moving north, the park appear on the left, and for the group moving south will find the park to their right. So both the group is said be in relative motion to one another. Bird and the airplane. Consider there is a bird flying at the same height that an airplane does. For the bird which in motion relative to the airplane, the passenger appears to be stationary. At the same time, for the passengers of the plane, the bird appears to be in motion and themselves in stationary. This way the motion of both the passengers of the plane and the bird are said to be relative motion to each other and also being an example of relative motion. The bird which has certain velocity will be relative to that of the plane in motion too. They both travel at the same frame of reference yet are said to be in relative motion to each other. River and the water. Consider a boat to travel across the river, and we will encounter two different scenarios with the relative motion of the boat and the river. Now let us assume the water in the river to be still. Now the boat will move across the river with no perturbation with the constant velocity, hence the boat will reach the opposite of the river with constant velocity and will not be diverted at any cost. Now say the water in the rover is flowing and the boat will not move in the same direction. The reason being, the water and the boat are relative to each other and the speed of the water flowing will affect the speed of the boat and the boat will move rightwards and reach the across the river. Car and treadmill. Let's consider the motion of both battery toy car and a treadmill as an example of relative motion. Now the notion is that the car has to move across the treadmill. Assuming the treadmill is stationary, we operate the batter car to move across the treadmill. The motion of the car seems to be not affected since the treadmill is stationary. So the car will reach the destination straight across the opposite of the treadmill. But when the treadmill is switched on, and also the car is operated, motion of both the treadmill and the toy car is in relative to each other. Now the toy car will not move in direct path as earlier because the motion of the treadmill is in relative to that of the toy car. When both are said to be on relative motion, either of it seems to be motionless when viewed from their own frame of reference, and this satisfies to be a good example of relative motion. Motion of table. At home, when we shift things from one places to another, we come across the concept of relative motion, but they go unnoticed. For instance, say we move one table from one room to another, there seems to be a motion, and we also move along with the direction of motion of the table. Assume there is a pet dog which moves here and there aimlessly, it will have a motion which is relative to the motion of the table. The reason being, when we move the table in one particular direction, the dog moving in the opposite direction will be in relative to each other. It is a very common activity, but we can as well find the relative motion concepts in each and every motion of the objects. Solar system. Solar system is one of the best example of relative motion, as the motion of each planet is relative to one another. We consider the relative motion of the Sun and the Earth. Earth is a planet which rotates on its axis that cuts through its center. The process of rotation of the Earth is relative to that of the rotation of the other planets too. Now when the Earth rotates on its own axis, it simultaneously revolves around the Sun too, and this is the main reason for the day and night on Earth. When part of the Earth which faces the Sun will be the day at the same time, the darker side of the Earth that does not face the Sun is the night. And this revolving moment of the Earth is relative to the rotation of the other planets too. The rotation of the Earth is different from several other planets too, and also the time taken for different planets to revolve around the Sun is different. For example, it takes 10 Earth hours for the planet Jupiter to make one day. And of Venus it takes 243 Earth days. Hence, although the motion of planets are said to be in rotational motion, they are relative to one another. For instance, if we stand on other planet and view the Earth will be in motion, but we seem to be in stationary state, although the planet on which we are standing in on constant rotation relative to the Earth. So we can give as many examples of relative motion to say that each object in motion will appear to be relative to one another. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.